tap headshot, you know, establish dominance in the game.
Shut up.
Grudges, you and I were going B side, right?
Yep.
Alright.
Is your flick shot good?
It was a little bit when we were playing. I was playing a solo with Grudges to kind of get a super set. Dude, this buy phase is just toxic. Okay. I want this map though. That's the only thing, Grudges. You gotta give me some pointers.
Shoot people.
I want a real Leicester map. I want to play a real Leicester map. We'll get like the Division 1.
I got the guy behind me. We're good. Move on.
Bros, did you remember Division 1, season like 4?
He shot through you to hit me. That's awesome.
Shot down.
Alright, I killed 2.
I have the spike. My ult is ready.
Alright, Grudges. It's just us here. You wanna chill or you wanna push? I think we're being lasered or like trapped, so I don't think we should push. Right here, on me. I'm reloading, wait.
Last player standing.
I'm stuck in place. I don't know if I just died and took a minute, but like.
I'm gonna catch you here. Check it out.
Yeah.
Never give up.
Yo guys, that's how you do it.
This is my first time
This
playing
is literally my first time playing as well, man. But I played Csgo before.
Bro, really saying.
I'm so hyped right now. I'm so hyped. I'm so excited for this game. I'm so happy.
Did you just get it?
I literally just got it right now. I got the key drop and then me and
Watching
Grudges-
streams?
Yeah.
I watched
Well, I wasn't actually
streams
watching it.
when
I
I
was
got
just basically putting the stream on, you know, like everybody else did.
Yeah, same.
Gone.
Enemy spotted.
Oh, I couldn't trade. Alright, I got him. I got the wall hack thing. I don't know if I think I killed him. Yeah, I did kill him through the wall. Oh, nice. I don't think he had a
Do him in there.
Right here.
I'm falling back. I'm so glad.
No more. Stay down.
Nope.
Dude,
On target.
you got covered.
One enemy remaining.
Dude, what is happening? Oh my god, I feel like I'm...
Last player
This guy's so better
standing.
than me. This guy's always killing me. This is the good player, the fire scar. This guy always kills me.
Dang.
I got so many kills. I got 15 kills. I'm lying. Oh yeah, we gotta go.
My ult is ready.
Got him.
No.
Yeah.
There's
Silence.
one more in there.
On target.
Oh, our team's getting...
Bullseye.
Let's go.
One enemy remaining.
Clean.
Up behind me, so I got him.
No chance.
There's one more, like behind. There's one.
Bullseye.
How are you not dead? Okay, go to the teleport. Teleport.
Enemy remaining. Attackers win.
GG guys, GG.
GG.
But hey, we can't even see the scoreboard. It just went up that quickly.
Should tell us 27-16. 6-13 was the overall score.
I was top kills, not bad. Equip card, sure, why not? How do I go back to the escape? Econ rating, first blood, plants and fuses. It's KDA. Interesting, timeline. Oh, this got some cool stats in here. I'll have to check these out later. Well, there you have it, YouTube. My first ever Valorant game. Lost. But at least I was top frag. Hi everybody, and welcome to the almost last CS 302 online. And yes, you did see a little thing here move. That's my dog, so don't panic. Dog here. Yes, she's just chilling down there. So we have somebody that's already talking about skeleton code. That's funny. Redeem release skeleton code. Posture check will be for my dog. So anyways, I'm very excited. Today we're going to be talking about the final project. And before we get to that though, I want to cover the algorithm first. And then from there we will have a big thing for you guys. First of all, I guess since that has been redeemed, there will be a light version of the skeleton code that will have to be given to Hex Tech Inc. And then we'll talk about anything beyond that later. But I am very excited. I'm going to be showing you a little bit of a demo of the ongoing solution for assignment 12, which is still work in progress. I expect to finish the entire assignment either today or tomorrow, but I have enough to already show you and talk about it. And then of course I will, we'll be wrapping it up and creating some sort of PDF within the next day or so. I'm very excited. Assignment 12 I thought would be easier than assignment 11. I have now come to the realization that it is harder indeed, and not because it's logically harder, but because there's more room for problems if you're not careful. I was working on this all night, and some problems just held me for a couple of minutes, and some held me for almost an hour, and they were just basic logical things. But here's the good thing. The good news is I took a long time doing it because I was developing from scratch. When you're doing it, you already know what worked and didn't work, and therefore you should be able to do it much easier. So, okay, but before we do that, we have got to cover the algorithm that assignment 12 is going to be based on. And it's actually very easy algorithm because, not because it's an easy algorithm, but because we already covered Prim's algorithm. And you'll see that this is just a very little modification of Prim's algorithm. Rip migrated for assignment 12. I am the teacher indeed, but I'm coming it from scratch. And coming from something from scratch is tricky because you have to realize, like, okay, let's think about, for example, assignment 11, like coding that for the first time ever. Like, what am I going to use for implementing this? And what am I going to use for implementing that? You experiment and try different things and see what works out the best. And something might work out, but it's just disgusting code and very hard to follow. And then you're like, well, there's no way I can give this a skeleton code, or there's no way I can give, I can make you guys code that. So there's a big difference between coding something for the first time and actually developing it. Did you guys get a wing ad? I did not get an ad, and I hope that doesn't happen again. but we'll see. But there's a big difference between coding something for the first time from scratch and not knowing anything about it versus already me telling you what works and doesn't work. And so that's pretty much the big difference between me coding it and you guys coding it. You will know what works and doesn't work versus like, hey, let me try if I can add this to the project. Okay, this doesn't work. Let me add this instead. Can I use this data structure for this? Can I use this for that? That's a whole adventure of its own. If you were taking 202 with me last semester, you had a project like that. There was one project where I just said, like, go wild, do whatever you want, but you have to do this topic at least. I think it was with virtuals or something, and people did some really cool things, like really cool things actually. But some people said it was hard because doing something from scratch is hard indeed. I haven't eaten wings in a long time. Not a fan, but okay. So, all right. I am super excited. I was so excited that I actually had a hard time trying to go to sleep, and so I slept very little. So, yeah. Okay. And yeah, sometimes skeleton code can make things harder than they have to be. Okay. I put the graph twice so that we have a backup of it. So, today we're going to be talking about Dijkstra's shortest path. Okay, and hopefully this takes us maybe 40 minutes at the tops, and then I can just switch on to hardcore project mode and we can talk about the big question, which is going to be a poll for everybody here on Twitch. Do we make the final cumulative or only based on anything that was not in the midterm 2? And that would be to help ease the burden for the final project, which is going to be the big media. That's going to be your real final, to be honest with you. I already know the answer. Do I? I mean, I don't know. I think sometimes I know the answer to, or how people are gonna feel about something, and then they feel different about it. So I've learned not to trust that what I think is the same that what other people might think. You know, you have to be humble, and that other people think differently. So we don't know. You never know. Some people are better at task taking than homework. You know. Okay. So I tried to color that to fix this imperfection, but it didn't work. Are you guys still getting the boneless wing thing ads? That's just scary. I hope not. We'll see. I'm scared about that. So, shortest path problem. So, if we were talking about minimum spanning trees, the idea between minimum spanning tree was the least amount of weight to connect all vertices together that were originally connected, right? And so, we did not care about the overall length from the beginning to the end of the path. As the assignment says, you don't care about being able to communicate between different mimics, and if that's not the shortest path to the omega, as long as the path between each mimic is as small as possible, so that those signal hops, can actually be done, right? It's much easier to do a bunch of signal hopping than it is to try to send a signal over a big gap of space. So minimum span trees is a really good thing to do for things like signal and things like that. But in other situations where you don't care if you do really, really big gaps, as long as you're trying to get there with the lowest cost, that's where shortest path is going to come in. That would be like saying you have a car with you have an electric car. Electric cars, we're getting better, but like back in the day, they didn't get that much miles per gallon, like pure electric cars, or sorry, not miles per gallon. They didn't get a lot of range. Maybe they had 100 mile range, 150 mile range. They didn't have what a normal gas car would have, which is like 400 mile range, right? Or 300 mile range, things like that. And so the solution of can I make it to this city using this electric car would be more of a minimum spanning tree, because you don't care about it not being the longest path, the quickest route to get there. You care about a route that takes you to enough charging stations so that you don't run out of gas. So the biggest gap between charging stations is something your car can handle. So let's say you're going to LA from here, and you're going from here to Victorville, and then from Victorville to Baker. Well, I guess backwards. So from here maybe to Bakersfield, and then from Bakersfield to Victorville, and then from Victorville to like actual LA. You make those 3 hops, and it happens to be the fastest route. But what if your car can't make it all the way to like Bakersfield or to Baker? I can't remember which was the one that's actually the way. But let's say you can't make it. Let's say it's actually Baker. I think Bakersfield is not. Say you can't make it to Baker from here. Then you might want to take a route that's longer, but takes you to little towns where you can charge your car. Barstow, that's what I'm thinking of. Yeah, Barstow. Thank you. Yeah, Barstow, that's it. That's right. Yeah. So if you're going from here to Barstow, and then from Barstow to Victorville, and then from Victorville to like actual LA, you're, as long as you can actually charge gas in those places, you're good. But what if I just came up with a brand new highway that was nonstop? It's Barstow, Bakersfield. No. But that's if you want to go north. I think if you want to just go to LA, I think it's Barstow, Baker, Victorville. I think that's the best route. I can't remember. It's been a while. But plus, I don't actually like look at the town names. I just drive nonstop. But so let's say that you were trying to you could not make it directly there. And in fact, I do remember it might be in Barstow where there's like well, I don't want to advertise for any company, but there's like a hamburger place that has like Tesla charging stations, super charging stations, right? And so those are good because I think they charge your car faster than like any other electrical charging station. So anyways, the point is, the fastest route may involve having to detour a little bit to charge. And so if I said, okay, I'm going to come up with this brand new highway, but it's nonstop. It's right from here to LA. It's a little faster because it's nonstop. So it's a straight run all the way to like downtown LA or something. But you lose the advantage of not having able to charge gas. So while that is faster, your car may not be able to make it. On the other hand, if you have a gas car that could actually make that distance, then you don't care about all the little stops that are the gaps between different cities are small, because you don't have that problem. You can actually last that long with the car. In that case, you want the shortest path, whether it takes you through a lot of different nodes or it's a straight run, no nodes at all. So if you're trying to go from 0 to 4, and there's a highway, like let's say that like a different example. Let's say this is Vegas. This is my house, and this is UNLV, and this is a 215. If that path takes me 20 minutes to get there, you know, and then the other shortest, fastest way to get there is through street roads, and it takes me I don't know, like 25 minutes going through here. I mean, it actually, looking at this thing, it does seem like the fastest route to get there would be probably something like, yeah, probably this. I don't know. We'll figure that out when we do the algorithm. But anyway, suppose that's the second fastest way. The fast way, that's basically 21 minutes. Okay, so that's slower, but you're going through little hops versus the big one, which is the highway, right? And so for certain problems, we want to get there fast, and for other problems, we want to even just be able to get there by taking small hops that we can actually handle. Okay, so that's kind of the difference between shortest path and minimum spanning trees in terms of application. Shortest path is very, very useful, and like I said, there's a lot of different algorithms for it. This is one of them. This is Dijkstra, the one we're talking about is Dijkstra. But as you will see, and as I said at some point, sometime, I remember I said it, I don't remember when. Dijkstra only works for positive paths or positive edges. It will not work with negative edges where you do like the whole time travel thing. For that, there's other algorithms that you'll learn. You'll learn about, I think, 6 of them, if I remember correctly, in analysis of algorithms. And that's pretty fun to learn, actually. And so there's different approaches, but Dijkstra is a nice, clean one, very fast, but unfortunately limited to positive edges, which I would say very few scenarios have negative edges, to be honest with you, because very few times you need to worry about things like time travel, right? Or having something negative. If you're trying to do Google Maps is all Dijkstra, and Google Maps has no negative edges. And there's no road that's gonna bring you back in time. So you could actually apply Dijkstra. And I remember at some point, if Kyle was here, when I did his 302 class, I actually try to research that and see. And I do believe they use Dijkstra as their algorithm. Although technically, to be fair, there is the idea of A-star. I'm sure you've heard of that name if you've done anything with gaming and things like that. A-star is going to be Dijkstra with an added heuristic, which, if I get a little bit of time, I can talk about at the end of today or next week of what A-star is. But A-star is nothing more than Dijkstra with a little heuristic in addition to that. And that heuristic is just a sort of a help to it. And there's a really, really good video. It just came back like literally right now. There's a really good video by somebody that speaks in like a British accent. And it's from one of those websites that means like Code Lover or something like that. And they're giving the example of Dijkstra versus A-star using the UK roads. And I will find it and I'll post it. But that was a good video. It just came back to me right now. It literally just came back to me. Yeah. Remind me about that video. I'll find it. Yeah. I'm sure I have it in the old in the old Canvas page for when I did 302 a year ago. Yeah, a year ago. Yeah, but like I said, we will do an example with A-star if we have enough time, and I think we will because the review shouldn't take that long, anyways. The final is 2 weeks from now. No, it's a week from tomorrow. Actually, the final is a week from tomorrow because tomorrow, reminder, you have the ABET assessment test, which is 60 minutes long, which should hopefully take you under 20 minutes to do. It's a 14 question, I think, multiple choice test that is assessing your understanding of the content and how the course is being taught and things like that. So the grade will not affect your grade. However, it will affect my evaluations of the course and how I change the curriculum next time around. So like if everybody does really bad on the AVL stuff, then I'll spend more time on the AVL and I'll have to cut from something, that kind of thing. So I take it seriously. And because it's multiple choice, you're grading immediately after. And a minute after the thing finishes, so it's from noon to midnight tomorrow. So at midnight with 1 minute, again, don't talk about it beforehand on Discord, but after that, you should be able to see the answers automatically. Like before, I had to manually do that for the last test. For this one, because it's multiple choice and I have a preset to be able to auto grade everything. First of all, you'll know your quote unquote grade until, as soon as you finish, but then you'll see all the right answers afterwards. So yeah, similar for test 2. I do know that everything else is graded though, so that's a good thing. As for test 2, I'm assuming that's the only thing they have to grade right now, so hopefully they get through those. I know that, like I said, literally like 2 days before after the test, I saw the first grade go up. I don't know if that was just like a thing where they just did one and then gave up, or if they're still working on those. So yeah, they say that they allegedly they forgot to make everything public beforehand. I don't know. I don't know. Benefit of the doubt. You know, the TAs work in mysterious ways. Oh yeah, so we won't have another worksheet. I can make one, but then I won't make it actually do. That would be basically MST, depth first search, breadth first search, and Dijkstra. Okay, so we can make one and then kind of work it out during class, and I'll make. Oh, I mean, I can make it if you guys want, but it's just more work. It's up to you guys. Or I can just make it optional and then go over the solution. So, yeah. Okay. Anyways. Yeah, I'll just post it out there and then we'll go over it, and then it won't be for credit per se. Yeah. So, which is basically, like I said, just do an example of those. Mystical Space Typhoon? I have no idea what that is. So, okay. So, as I was saying, the way you actually solve this, and maybe actually I will solve it first using kind of like a by hand method, and then I'll solve it using the algorithm. But the algorithm is almost the exact same one. I've never played Csgo as Prim's algorithm. There's one tiny difference, other than not messing up like we did that one day. There's one tiny difference in the algorithm between Prim and Dijkstra, and that is going to be that in Prim's we were replacing the edges if we found a lower cost. This time you're not replacing, you're adding on to them, and you're keeping like a running count of the edge cost to get there versus the last connection edge. Just kind of, why are you guys getting ads at random times? That's so disruptive. Did that start after I became affiliate, or was that always the case? Now I'm wondering. Pot of Greed, dude. I have no idea what Pot of Greed does. That's so sketchy. After affiliation, I have to figure out if there's a way I can turn that off. But I do know that ad block is actually useful against ads on Twitch. Like I know for sure that you will not get an ad if you have ad block. I mean, like, I have a way of clicking a button that says like run a 60-minute break. So I mean, I could do that if I'm going to go to like a bathroom, but I have nothing else. So I'll have to finesse it. But that's kind of especially because it's so random. So like I can't even predict it. If I could predict it, I could at least like, do something about it. Allows you to draw 2 or more cards. Oh, I don't know. Interesting. Okay. So anyways, I guess we'll do the example by hand, and then we'll do one with the algorithm. Although frankly, this is one of those cases where the algorithm is easier. Okay. So the idea is, for the actual shortest path, is to find the shortest path for all nodes, giving a starting node. In our case, the starting node is going to be 0. We want to find the shortest path for all nodes. And so, typically, again, this will only work for positive edges, this algorithm. So, already here, because you can only go from 0 to 1 in 2 ways, basically, this is going to be the shortest path right here. This right here is going to be the shortest path to 1. Guaranteed, because the only other edge coming out of 0 is already bigger than that. So that's good to go already. So that will be the first step right there, is to put that in, okay? And then after you put in that edge from 0 to 1, you're going to look at what edges are available and pick the slowest cost. So you got the edge here, and technically the one that I already highlighted, which was the other 8. So you go ahead and you pick any of them. So in this case, just because I already highlighted it, we'll pick that one. And so that's going to get you to 7. Okay? And so from now, you got a bunch of options to pick from. You got this one with 8, this one with 11, this one with 7, and this one with 1. You're going to pick the smallest cost and you're going to add it in. So in this case, that will be the 1. Okay? From there, you got even more edges that are actually available. You got this one still, this one, this one, this one, and this one. Obviously, you pick the smallest one, and so the smallest one turns out to be the 2. So you add that in to your list of nodes. And again, you keep track of what's visited and that sort of thing as well. But from there, you got even more edges to add. And so you're gonna go ahead and pick the smallest edge to add in there. So you could add in that. And then from there, you would add in the 2. And here's the thing though. Notice that to get to 8 from 6, this path would take 2 plus 4 plus 2, which is 8, right? So, however, this path can take 6. So that's a faster path to 8 than this one up here. And because of that, we're going to do what's called the relaxation. So that's the 2 big steps in the algorithm is the relaxation step. And that means changing, which we kind of did relaxation when we were talking about the Primes algorithm, which means instead of making this be the way to get to 8, we would make this the way to get to 8 right there. Okay? Furthermore, there's one thing here. When I'm comparing edges, you want to keep track of how much it took you to get there. So one of the things that you typically see in examples online and things like that is you put a little number here to remember how heavy it was to get there, how much weight. So for example, here's a 9. Why is this a 9 here? It's a 9 there because you're no longer like in Primes, you're just considering that last edge. Now it's actually like an additive thing. You have to add the 8 here and the 1 there, and those together are going to give you how much it took you to actually get there. And if there's a faster way, then you would replace it with that. So from the 9 here, this would take 11. And then let's say for this 2 here, this 2 would take 11 plus 4 is 15. However, if you were to go in this direction here, it would be 4 plus 8, which is 12. That's smaller than 15. So if you were coming from 5, you would now change to come from 1, and that would be again a relaxation step. If you've done this side first and then you try to do this side here, then you would simply not update it because 12 is already smaller than 15. Okay? And then as we were talking about with the 8, there's 2 ways that we can go to the 8. One of them is to go 9 plus 6, which would be 15. And the other one is to do 12 plus 2, which is 14. That is faster than 15 by 1. And so therefore, this is actually the most ideal distance to get there, and not this one over here. Okay? And so we got left this 3 here. So there's 2 ways that we can get there. We could get this way, which would be 12 plus 7, which is 19. Or we could also go this way, which would be 11 plus 14, which is way, way bigger than 19. It's 25. And so we would want to keep that one in there. We would want to check, though, this way. See what 12 plus 4 is, which is 16. That's bigger than 11, so nothing gets updated there. But for the last one, the 4, we have 2 ways, this way or this way. If we take the one at the top, that's 19 plus 9, which would be, this is where the lack of sleep comes in. What is 19 plus 9? 28. 28, yeah, 28. And on the one down there, it's 11 plus 10, which is 21. That's much smaller than 28. And so you want to take that one instead. And there you go. At this point, you have found the shortest path to all nodes. And that's pretty much it. That's the algorithm right there. Easy. Piece of cake. How you guys feel about that? Now we're going to do it algorithmically, of course. But that's just kind of the hand waving. I have a whole map. Yeah, I know. It's swinging down. What I can do is I can just bring the camera down and you don't see it anymore. Yeah, I don't know why. I think the fabric is stretching back there. That's why it keeps doing this. It's sagging a little bit. Does the algorithm change if we need to find shortest path to a specific node? Well, here's the thing. This algorithm will return to you once we remember with prims, when you do the algorithmic way, you have the parent node thing, and then you can just backtrack all the parent nodes to be able to find out. Because when you do this algorithm is expensive in terms of complexity. I should have written it up here. I believe it's b cubed. But anyways, it's an expensive algorithm to compute. But once you compute it, it will give you the shortest path from a starting node to all nodes. So what's the shortest path to get to 2? What's the shortest path to get to 5? And typically, if you want to remember how to do that here, you can put a comma to these and put the source node. So for example, I could put 12.1 here. I could put 19.2 here. I could put 21.5 here. And the second value there is the parent node. And so you can backtrace to be able to find the shortest path to a specific node. So the algorithm doesn't change. What changes is the starting node. That's pretty much it. And it's a little bit backwards because, you know, when you finally get the solution, you're going to get it from the end to the beginning versus beginning to end. But that's okay. You can just print it backwards afterwards. So yeah, just pick the node that you want. And now you're saying, well, I don't need to find the shortest path to every other node. I just want to find the shortest path from 0 to 2, for example. Or from, let's say you want to find from 0 to 4. Unfortunately, Dijkstra's will give you not just the shortest path from 0 to 4, but basically from 0 to every other node. And that's not a bug, it's a feature in the sense that there's no other way to do it. Because to be able to find the shortest path to 4, we need to see the entire graph and understand how it's built. And the shortest path to every other node will tell us that, so that we can then figure out how to get fastest to 4. And the shortest path, by the way, is indeed the minimum weight of all edges combined, regardless of if it's one big edge or a lot of tiny edges. Again, different than minimum spanning tree. Minimum spanning tree, it was the sum of all edges to connect the entire graph. Here, we care about the sum just to get to that destination node, regardless of if there's cycles or not. As you will see, typically there isn't any cycles, but it's possible that there may be, okay, here's the thing about cycles with Dijkstra's. If there's a cycle, it's a waste of time, right? The shortest path is never going to involve me visiting the same place twice. So you shouldn't see a cycle per se, but it's not going to be the minimum spanning tree. As you can see here, this is not the minimum spanning tree of this graph. If we remove the edge that we didn't work with here, which I think is this one. Yeah, this edge we didn't work with here, so it's not part of the graph. Okay, that's not the minimum spanning tree of this graph. As you can see, the minimum spanning tree would have picked the 9 over the 10. It would have picked that as part of it. But that would be the minimum spanning tree. The shortest path is going to pick the 10 because locally, yeah, sure, 10 is bigger than 9. But from 0, it happens to be the fastest way going down, even though it's a little bit longer there. Okay? So that's a little bit abstract. So anyways, let's see if I have a formal definition of Dijkstra that I could throw in here. If you go to Geeks for Geeks, I'll post a link of that actually right now. I think they have the same graph. Anybody look at the book and see what they have? I'm curious. There's a link. And so, as you can see, this is very similar to Prim's minimum spanning tree. We maintain 2 sets. That's just explaining the implementation. Although it is kind of confusing here. The one thing that they don't talk about is the parent. Keeping track of the parent. And not doing what we did with the Prim, which was not update edges of visited nodes already. Which is probably why I made the mistake, because we don't make it obvious. Oh, at the end of this, they talk about the parent array. I guess the parent array isn't always in there. The time complexity for the implementation is v squared. I said v cubed, I think. V squared. My bad. I apologize for that. So, I'll put it here before I forget. since I like to put the time complexities up here. Apparently though, it can be done in E log V if you use a binary heap. That rings a bell with prim. And then it also says here, this is the one that I thought, but I want to say it because I want to be mistaken. Bellman-Ford is another algorithm for shortest path that can give you negative edges. Why can't I spend 1,000 for the skeleton code? Somebody already spent it. What about space complexity? Space complexity depends on how you store it. Adjacency list, adjacency matrix, just pointers. And at that point, whatever the space complexity of those algorithms gives you, like adjacency matrix is going to be squared, right? So it's going to be based on how you store the graph itself. There's no extra space really needed for the algorithm other than that little table. And that's just n tier, so it's not really, it's irrelevant. Someone on Discord even searched how to turn ads off on your end. Oh, they did? Oh, I don't have Discord open on my computer today. I'm sorry, guys. I'll open it right now. Let's see if I can do that really, really fast. And then I'll turn it off. Pre-rolls. You're updating by default for pre-rolls, but suddenly might just say mid-roll ads. Is it something I can actually achieve within like a minute? Let me try it. There will be a toggle in your revenue settings page. Okay, let's do that real fast. The question is where the revenue settings page even is. Okay, here's the affiliate page. And then affiliate onboarding, payout methods, subscriber only chat, hype train. It is disabled. It says, I'll show you guys. Pre-roll ads. Disable pre-roll ads when I run ads. Keep pre-roll ads on my channel. There's no other option, basically. So I don't know. I'll have to finesse with it later on. So, but yes, ad block. You should have ad block, you know. I guess we got scammed into the affiliate thing. Now you guys are stuck with that. That's horrible. I'm sorry, guys. Worst case scenario, I'll make another Twitch account. Okay. I don't know. Anyways, I don't want to waste too much lecture time, so I will experiment with that later. Okay. So, anyways, let's just jump right in to get this done, because I really, really want to talk about the assignment. Like, you have no idea how I really want to talk about it. In fact, actually, here you might be able to. From the notes from when we did prims, let's pull out that one chart that we had. This one right here. Yeah, this is the one. Actually, while we're at it, let's pull out this entire algorithm part, because it's very, very similar to the one that we're going to be doing. So might as well copy and paste the entire thing. That's from the 22 classes ago. Okay. Oof, I thought I cut it off for a second there. Huh? Question mark. There we go. Okay. All right. So let's go ahead and reset everything here. Okay, and then no parents. They're like Batman, you know. Hope you all are doing okay in these COVID-19 times. This lecture has been sponsored by COVID-19, as usual. Okay. So, the only thing, I'm good. I've been good so far. The only thing we're gonna change in this algorithm for prim is gonna be in the line. Yeah, right here. I think this is the only thing we gotta change. So, hey, if you did prim for assignment 11, you may be able to actually take a chunk of that code and use it in assignment 12. Oh, did you see my doggo chilling? Yeah. You might actually be able to do that. So I guess if you haven't done anything yet, you may want to try out and just go straight to doing prims for that assignment, because it'll actually help you out for the final project. Okay, that's it. That's the only difference. I think I think that's it. I mean, I'm not 100% sure, but we'll see once we do this. But I think that's the only difference you have to do that in the pseudocode there to update this to Dijkstra. So Dijkstra was like, "Yo, how does the meeting go? Can I have your homework?" So Dijkstra asked Prim, "Hey, can I have your homework?" And Prim was like, "Yeah, just change it up a bit." And then I basically added, and Dijkstra just added this line, or the other way around. I don't know who came first. So. Yeah, basically, okay. So, yeah, I'm trying to think if there's anything else, but I think that's pretty much it. Okay, so because that's pretty much it, you will see that this is pretty much just like us, redemption time for the mistake that we made, right? Even though I made the video again, So let's not make that same mistake again. So we still keep track of the same things: the key, the parent, the visited, and the vertex themselves. And so you just go ahead and just grind out this algorithm. So I'll just do it in place, and you can use the video to see, so I don't have to copy paste a bunch of times. Okay. So let's jump in and let's hope for the best. All right. If not, then this part of the video will be intercut with the one without a mistake. Hopefully there's no mistake though. So we are again going to go ahead and set everything to infinity that has not been visited. That's the first thing that we got to do, I guess, as part of the initialization process. With the exception of the key that we're starting with, which is 0. So in this case, that will give it a value of 0, and that has no parent because it's really much the start, okay? So, and nothing has been set to visited at this point. So the visited array is set to false, okay? Now we're gonna add in all the edges that are adjacent, or all the vertices that are adjacent to 0, as in that there's an edge that exists between 0 and 1. Those are the two edges, 4 and 8. Okay? So edges 0 to 1 and 0, 7. And so in this case, we are going to go ahead and just, so far this is the same as prim. We're going to go ahead and throw those in here by updating the weight of those. Let me take my watch off, because it's gonna, it makes confuses the tablet with the metals and stuff. So there we go. Okay. All right, so this is 4, and then this is 8, and don't forget to update the parent to 0 for both of these, okay? This is prim so far. This should be identical to prim at this point. We mark this as done. Visually, what we've done is we basically checked these two edges. All right, next we're gonna pick the smallest number there. 4 is smaller than 8, so we're gonna pick that. So we're basically visiting at this point. Oh. I guess I don't want to have the whole color coding thing, but we'll do a little bit of it. We're there now, okay? So from there, we are going to go ahead and we're going to check all the edges that are adjacent to that are connected to vertices that have not been marked as visited, which means we're not going to check the edge again here. We're not going to do that edge again. That's the problem, right, that we did the other time. We're not going to touch that. We're not going to touch that edge. Do not touch that edge. Okay, that's most of me telling myself, but yeah, we will, however, go ahead and work with the two other edges. So in case of the 2, let's do that one first. That's infinity right now, so anything is better than infinity here. So 8 is going to be updated there, and our source node, which is the one we're currently working on, which is going to be 1. Okay, all right. The other edge 11 is 11 smaller than 8, basically. Oh, oof. Okay, we almost screwed up, guys. We almost screwed up. Otherwise, this would just be prim. We have to keep a running sum. So we don't put 8 here. We put a running sum of the edges to get there. So that will be 4 plus 8. So 12. Yes. Close one right there. So you can think of this as a 4, 0 here. And this is so far saying 8, 0. And then this says 12, 1. Okay? So almost screwed up, guys. Almost, but we caught ourselves. The corona reminded us to stop for a second and make sure we didn't screw up. Okay? Cool. Finally, we look at the edge from 1 to 7. So the edge from 1 to 7, we want to compare, because again, we need to do V key plus W. We are saying, I guess that would be one of the things that we could modify in this algorithm to make it match. Instead of saying if W is less than V key, we're saying if W is less than I'm trying to see how we can introduce the fact that we're adding to the if statement. We're taking the old value of U. So I guess maybe we can do something like if U dot key plus V dot key. I think that's okay. Let's think for a second. Help me out, chat. We want to check, because what we're doing is when we get to 2, we're not just checking, we're not comparing the 8 to infinity. We're comparing 8 plus the current weight here, which will be 4, to infinity. So I think that's right, because in this case, U key would be 8, or sorry, that would be 4. U key would be 4. This would be 8, which would be 12, and we're saying it's 12 less than infinity. Yeah. Okay, I think we're good like this. I think we're good. Ooh, sorry, I elbowed my dog. So, okay. So yeah. Okay. I think that's the pseudocode for this. Again, this is not something that I had pre-planned. We're kind of working this out because I don't like just having it pre-planned, because then I'm just like, yeah, this is the pseudocode, and then even I don't know what's happening because I don't remember it. Versus if we work it out ourselves, I think it's much better because we understand it. So anyways, now we worked it out, and I think that's gonna be good. Okay, so going back to this, we are gonna look at the edge from 1 to 7, and so we're saying 4 plus 11, which is 15, is that less than 8? And it is not. So in that case, that edge will not update. Okay? And I'm just gonna be marking all the edges that we've worked with so far. Okay? All right, so good. Good. We're done with 1 now. Okay? So now we move on to the next one that's available. We got 2 options. We got 2 and 7. 7 is smaller than 2. So we go with that one. Okay. We're at 7 now. That is green. Fail. We are at 7 land. And in 7 land, we have 4 edges, of which 2 of them are not okay to visit or to look at, which are the edges going from 7 to 0 and 7 to 1. Because those vertices have been marked as visited, we don't want to mess with that. We mess with that, we screw everything up. So really, we only got to work with 2 edges here. It turns out that for both of those edges, right now things are set to infinity. So that's going to be basically anything that we have here is going to be smaller than infinity. So for example, for the edge, let's go ahead and do this edge first here. It's always a good idea to go with the smaller edges first. It'll be a little bit faster. That's probably where the binary heat pair comes from. So that edge right there means that we're gonna, and again, make sure we don't screw this up. We are taking the weight of 8 adding 1 to it, and then that's what we're putting in here. So here we're actually putting a 9 and putting our source to be 7. Okay? That's what we're comparing with infinity. We're comparing 9 with infinity. Not 1, not 8, but 9. Okay? That's the tricky part. That's the only real difference between this and prim anyways. So, very easy to get these confused. Don't get them confused on a test. And then the same thing with vertex 8. We're saying 8 plus 7, which is 15, with a source of 7. And then we can confidently say we have finished working on that node. We good so far? Any questions before I keep going? Dog was just chilling back there. All right. It's really making me hot, actually. It's like it's hot. Okay. So we got no questions. So then so far we got a couple of options here. We have nodes 2, 6, and 8. Of course, the real only option is going to be node 6 because it's the smallest one of them, right? So we pick that. We pick that. So that's going to be the yellow. Okay. So from there, again, we got 3 edges of which one of them we don't touch because it's already going to a node that we marked as visited. So really we only have to work with edges from 6 to 5 and 6 to 8. Let's go ahead and do that 6 to 5 edge first because it's relatively straightforward. Because so far it's 5 is set to infinity. So that's going to be 9 plus 2, which is 11, source 6. Okay, this next edge is going to be a little bit interesting here. For the edge here, we are checking 9 plus 6, which is 15, and seeing a 15 with a source of 6 is smaller than what is currently in 8. 8 has a 15. So in this situation here, you only want to replace the edge there if you find a smaller number. If they're equal, there's no need to replace it. What it means if they're equal is that, like minimum spanning tree, there's 2 routes to that spot that take the same amount of time. And it just happens to be that we found this one first. And so because of that, there's no need to update it. It's just a waste of space, okay? But I want you to understand what that actually means, which is, again, there's 2 routes that would have taken the same amount of time. We just unlucky for this one. We found the other one first. So there's no update, okay? All right, at this point, we are done with 6. Now we got 3 nodes available, 2, 5, and 8. Of those, 5 is actually the smallest with a value of 11. And so we're going to go ahead and pick that then. So that is pink. Okay. From there, we got 4 edges coming out, of which one of them we don't want to mess with because that one edge is going to a visited node. So we don't want to mess with this edge. The other ones we can mess around with. Let's start with the trivial ones, which are the ones that are going from 5 to 4 and 5 to 3, because right now those are set to infinity, so this will definitely update. So 5 to 4 is going to be 11 plus 10, which is 21 with a source of 4. Or sorry, I apologize, source of 5. So 21 with a source of 5. See, I keep calling it source instead of parent. So that might be because at some point somebody told me to call it source, but parent, same thing, you know. So if you want to call this here source instead of parent, go for it. It must be valid because I must have heard it at some point somewhere. And then the other edge that we want to update is this one. This is going to be 11 plus 4, which is 25 with a source of 5. you can already see ahead of time. That's because we solved it by hand before. That it's going to get updated later on. The source is a starting vertex, I believe. The source of the entire thing is a starting vertex, but we're saying the source of the current best path, you know. So I don't know. That's probably where I'm coming from that. But anyways, just a naming thing. Okay, at that point we got one more. We got one more that we got to work with here. We got to look at the edge from 5 to 2. The edge from 5 to 2 is technically going to be 11 plus 4, which is 15, with the sources parent of 5. And then we're looking at 2, which has a 12. 12 is, of course, smaller than 15, so no update will happen there. But we did have to check that. Okay, at this point, it's a good sign that none of these numbers are infinity anymore. It means that the graph was connected in the beginning. And now we just gotta finish the remainder of these guys by going with the smallest one. But don't forget, we worked with 5 already, so we want to make sure that's marked as done. Okay, so now we're going to be looking at 2 because that's the smallest number with a weight of 12. Okay, so let's go ahead and do that. We only really have 2 edges we got to look at there because we don't want to look at the edge from 2 to 1 and from 2 to 5. Those have been taken care of. We want to look at the edges from 2 to 8 and 2 to 3. Source makes more sense than parent, no? Because parent is for whenever there's an exact path to follow, like in a binary tree. These paths from node to nodes change depending on what you pick. That's right. So, yeah, if you want to think of it that way. So, like I said, it's a naming thing. So, call it whatever you want. I'm not going to be pedantic about the name conventions. So, I think source makes sense. I agree on that. Source makes sense to me. But to other people, it makes sense to call it parent. So, whatever gets you to remember it correctly in the test, you know, and in general. So, okay. Let's go ahead and look at these edges. So let's start with the edge from 2 to 8. This is where the fun begins. Okay. That edge, we're saying 12 plus 2, which is equal to 14, is that less than 15? Yes, it is. That means that we have found a new shortest path to get to node 8. And that shortest path is going to come from node 2, whether you call it parent or source. Whoa, relax. I think she heard something. Okay, I know what she's doing. So, because we found a new shortest path, this updating right here of us saying, okay, this is no longer the best one to come from 7, but now we're going to be coming from 2 because we found a number smaller than 15. It's not that big difference, but it's, you know, it's still smaller, so we update. This part of the updating process, the naming convention for that is called the relaxation stage, and it's typically a function you have coded. So you relax the vertex. I think that's what it's called, relaxing the vertex. Okay. Dr. Royale, when he teaches 302 or algorithms, he really emphasizes the word relax. It's really cool. It's in a way, he makes it memorable, which is a good thing because it helps you remember it. He's like, relax. He really extends the A in relax. And so if you ask Ben or anybody like about relax, they all think of Dr. Royale's relax. But it works because it really makes you remember that. That's what that's called, the relaxation stage. So relaxation stage is when you go ahead and you update to a new source or a new parent, whatever you want to call it, with a lower weight. Okay? So that's the relaxation of the algorithm. Okay. The same thing's actually going to happen with this edge here from 2 to 3. That is going to be 12 plus 7, which is 19, which is smaller than what we currently have in 3, which is 25. So 19 is smaller than 25. And that's a source of 2. So we have relaxed that node. Okay? At that point, we have finished working with 2. We're good. Now we got 3, 4, and 8. 8 is the smallest number, of course, because it has 14. And so, tired. we're gonna go from there. However, guess what? 8 has no edges that we can actually change because it has 3 edges, 2, 6, and 7, and all of them have been already marked as visited. So nothing can happen there. So at that point, we could just mark it as done. That's pretty nice. Looking at 3, that actually only gives us 1 edge to work with, which is this one. However, already before you even add the 9, 25 is bigger than, oh wait, no, technically, oh, snap. I forgot to relax, guys. That 3 there is 19 now. I just forgot to update it there. So 19 plus 9, there's no way that's going to be smaller than 21. You know, that would have to be a 1 literally to actually update. And it's a 9. So nothing will get updated at that point. So we can go ahead and mark 3 as done. And finally, I hope Dr. Wallace is doing fine. You know, maybe he'll watch this someday. If he does, then high five. I mentioned him in that interview. He's like an inspiration. So I do hope if you guys take analysis of algorithms, if you can take it with him, you'll enjoy it a lot. If not, Larmer is pretty good too. But, you know, I like them both. So, yeah. At that point, 4, same thing happens with 4. There's no edges coming out of that have been already that are unable to be changed because everything is marked as visited. So that, again, like Prim, that last vertex that you look at will have nothing to do and you'll be done. So really, once you visit n-1 vertices, you can consider yourself to be done. And so we have completed the algorithm, guys. Hype. So how do we actually print out the shortest path to a certain node? Worry not. The way you do it is you pick the destination node and then you work your way to the parent. So let's go ahead and do that. But for that, I'm gonna go ahead and copy and paste this up in the next page here. So I kind of leave that nice and clean. Okay, and then maybe, actually, I know this is all colorful, but I want to be able to color more. So let me find a uncolored version of that graph. Okay, so now that we have our little table here, if you want to find the shortest path to a specific node, chat, tell me, which node would you like to find the shortest path to? And don't pick 1 and 7 because those are kind of easy. Pick one of the ones near the end. But chat, let me know. Which node? 4. Oh, nice. There's like very few delayed today. That's amazing. So, great. Okay, so we got 4, 6, and 8. So we'll go ahead and do all 3 of those. Okay? We'll go in the order that they appeared. 5. That's enough. No more. We don't want to spend all day doing this. Okay? Thank you, Cox. Yeah. No, don't thank them. Okay. But, all right. So we'll go ahead and do that. So you guys want 4. So let's do 4 first. Do what the people want. So what you do is you look here at 4 and you find the parent of that, which says it's 5. So then you connect 4 and 5 together, per se, like this. And now you look at 5. What's the parent of 5? 6. Okay, then you connect that with 6. You look at 6. What's the parent of 6? It's 7. So you connect 6 and 7. What's the parent of 7? It's 0, so you connect that. And when you're implementing this, if you don't implement it as an adjacency matrix or graph or list, and you implement it as pointers, then you could actually just keep the pointer address in there as well. When you in the parent entry, you could actually keep the actual physical pointer. And there you go. That is going to be the shortest path for 4. Okay. Notice something. I'm actually glad you guys picked 6 as the next number. If we go ahead and find the shortest path from 6 to the start, which is 0, you'll see that it actually tells us that we should go from 6 to 7, and then from 7 to 0. So here's the interesting thing about this. Any node in the path from another node to the 0 node if you want to look at the shortest path for those specific nodes, is going to be the same answer. Why? Because otherwise, if it wasn't the case, if there was another shortest path from 6 to 0 that was not the one that I already listed from 4 to 0, so let's say that like there was some magical route that I could take from 6 to 0 this way that would be faster than anything else, then why in the world would I have picked that bottom one to get before? I would have instead picked that magical path, right? So I hope that makes sense as to why the shortest path from 6 to 0 is going to be basically the same path that 4 to 0 takes because it goes through 6 in the first place, right? So similarly, I'll skip ahead for a second. You guys want me to do 5. The shortest path, without even looking at the chart, from 5 to 0 is going to be this one right here. Because if there was a shortest path from 5 to 0 that was not this one, then the shortest path from 4 to 0 would have taken that path as well. That's an important thing to connect in the brain. So make sure that, let me know if that doesn't make sense. I can say it again. Finally, let's go ahead and do 8. So 8 says to go to node 2. And then node 2 says to go to node 1. And then node 1 says to go to node 0. And there you go. Yet again, if you had asked me to find the shortest path from nodes 2 to 0, it would have been that same path right here because it's part of the path from 8 to 0. Okay? So that's it. That is Dijkstra's shortest path. How do we feel? Easy peasy, lemon squeezy. Cool. That is the last algorithm that you need to learn for this class. Easier than Prim and cross goals. I would say it's about the same difficulty as Prim. Not harder, not easier. Again, you really only have to change those 2 spots in the algorithm. Easy, right? This is what you got to implement for assignment 12. You got to implement Dijkstra's shortest path algorithm, plus a couple of other features that I'm about to talk about. But that's going to be, of course, the algorithmic part of it. So now we can go ahead and talk about it now. Which 2 spots did we change again? We basically added a plus. I'll highlight them actually. That'd be a nice thing to highlight. This was added in, the V key part. And then this was added in here as part of the if statement. And if you saw my little rant on Discord at like 5 a.m., you want to be careful about the Boolean evaluation's priority or order of operations. So put that extra set of parentheses there, because I think if you don't, it's going to try to compare W to V key before doing the addition. So yeah. See that? See? The same thing happened that happened. It wasn't this exact case. I wasn't trying to implement Dijkstra in the morning when this happened, but it was something very similar to this. I'll talk about that afterwards. Okay, so moment of truth now. At this point, like I said, we are complete with the course in terms of algorithms. I will, of course, have one more class day, which will be next Thursday. So next Tuesday, I was thinking of doing review, and then on Thursday we can have a normal class day, because then having the review literally a day before the final is not going to help you much, I think. So that's why I'm taking review day on Tuesday and then normal class day on Thursday. And the class day on Thursday, I don't think any of that will show up in the final. If it does, it's like at the very, very broad level, like shallow level. But on next class, we will talk a little bit about algorithm analysis, the different types of algorithms that exist out there. And then we'll say like, okay, there's greedy algorithms. Which of these algorithms that we've done this semester are greedy? And we'll kind of analyze that. Then I'll give you an introduction to P versus NP and SAP problem and that kind of thing. And that'll pretty much be the end of the class. It'll be a fun, relaxed class because it'll be the day before the final too. And then on Tuesday, we will talk one more about the project as well and do the review. Okay? So are we gonna have an extra lecture to go over midterm 2? Good point. If we do, it's not gonna be part of the Tuesday-Thursday one. It would have to be some bonus lecture on the weekend or something that I can stream. If you guys pick a date that you want, and I'll do it. Don't do it tomorrow though, because I want to get the assignment done. But you can do it on Saturday, Sunday, Monday, Wednesday. Or I can actually go over it partially. Whoa. See, tomorrow. No, tomorrow no, because I want to get the assignment done, and like I want to just do that, and you know, I don't want distractions to do that. But here's the next thing that we need to talk about. Okay, so my question to you. So first of all, when is assignment 12 due? The big question. Okay, I'm gonna pop up calendar open here. I would make it due on the 14th or the 12th of May. I think one of those two. Not decided yet, because that would be when you would have had a normal final per se. So I think I could go with 14, but I want to check with the TAs to make sure that they can actually have enough time to grade it. 14 was the scheduled final for that. Okay, so tentatively we will do the 14th. If the TAs have really hard time with the time schedule for that, then maybe 12. But more than likely, unless further notice, 14th. That gives you exactly 2 weeks to do it, which is more than enough time, I think. Okay. All right, that's the first thing, I guess, that's important to think about. So I guess I'll write it down here for now. Okay. At night that day. That's the first thing. The second thing is going to be, of course, what is the final project? So, before that, I want to ask you to be able to focus more, because I think that the final, okay, let me put it to you this way. I'm so excited and so happy and proud of this final project that I think it's more valuable that you can do this as a programmer than anything you can do in a test. And so I would like you to focus more on the project than the final exam. And the way that I can do that without violating UNLV rules and things like that is I can change the final from being a comprehensive final to being a final that is only focused on the latter material of the course since the last test, which would be essentially the graphs. So that means that your final would be basically DFS, a DFS question, a BFS question, a topological sort question, a minimum spanning tree question, and a Dijkstra question. And that would be the full final. Maybe 2 minimum spanning tree questions if I wanted to do both. Or I could just make you pick one of the two to do it. Okay? That's one option. Maybe one theoretical question on the graph, because we did talk about the graph. What is the difference between adjacency list and adjacency matrix, and which one's better, and things like that. That's one option. Other option, of course, is to make the final comprehensive, which would mean it will be a longer final, yes. It would still be biased towards the later stuff, as I usually do, but there will be questions about recurrence relation, ABL trees, maybe a sorting question, and of course, tree questions in there as well. And then you get your graph questions, okay? So maybe you get 5 or 6 questions on previous material. So at this point, I'm going to go ahead and open the poll. We got 38 viewers, and then we'll let the people decide. Hopefully an ad doesn't play in the middle of this. New poll. It would be longer indeed if it was comprehensive. You said DFS, BFS, MST, Dijkstra, and topological sort. I did say that, yes. How long would it be? I mean, I could still give you like 3 hours to do that, but I don't know. I'll make the TAs figure out how long it would take them to do that. Mostly, it's going to be a lot of drawing. It would be the entire test would be literally one big upload. There will be no written questions essentially. What are the advantages of a comprehensive test? The advantages of a comprehensive test are that if that was the case, then I would probably only ask you one question of DFS and BFS and topological. I'd pick one of that. I still ask you a minimum span tree and I still ask you a Dijkstra. So it would be, let's put it this way. If you did really good on test 1 and test 2, but you just did not understand the graph stuff, then you may be punished more technically if it was not comprehensive, because you would not, because then you're screwed at that point, you know? You're basically screwed that to, if you don't understand any of the graph algorithms, you will basically get a 0 on the test. Versus like if you know AVLs and sorting or recurrent relations. If you really got that, but you did not get the graph stuff, comprehensive, at least that means you got about 2/3 of the material. So you get a 2/3 grade, you know. Hopefully you understand everything now. Which would you be essentially to focus? I mean, everything is important in this class, but I'm just saying the advantage of taking a non-comprehensive is that you don't have to review material that is older, which you may not have the time to do. So I think from a time point of view, making it not comprehensive would be less of a burden for you, which would give you a chance to focus more on the project. So let's go ahead and take the vote and see what you guys want. Okay, we're gonna go ahead. I'm gonna create a poll here, and you're gonna vote. We're gonna leave the poll open for 5 minutes. No, 3 minutes. 3 minutes is good. I don't want to have to wait too long. Should final exam be comprehensive? And response 1 is yes, full course. Response 2 is no, only on graph material. Material doesn't fit. Hold on, I guess I got rid of the space there. Allow additional voice using bits. No, I'm not gonna let that in. It does. You can use channel points though, but I think I'd rather make it fair. Okay. Start the poll. All right, the poll is going on right now. I'm gonna go ahead and show you how the poll is going, and then we'll see. So it seems right now that we got about 411. You got 413. It's about 3/4 to a quarter. Meantime, we're 2 dabs. Isn't cumulative better? There's pros and cons to both of them, I would say. Because yes, indeed, there's not as many in-depth questions per se, I suppose. You don't want to study recurrent relations and AVL rotations again. Your nose should be in your elbows for the ideal technique. My nose should be in. What? Like that. Recurrent relations haunt you. Don't worry, they'll haunt you in analysis of algorithms. But then again, at least you look at the master theorem in depth. Which exam do you think is better? I don't know. I haven't made either version of it. So, but this will be the first time I don't make a cumulative in history of all the times that I ever taught any class. I've never made a non-cumulative final. It's my hair. I got like a little spike here with my hair. My hair's getting really long. I've decided to try to cut my own hair after the semester ends. That way if I screw up, it's not on camera for at least a month before the summer starts. So we got, how long is it over yet? Oh, I see the little bar is the time. So it's looking, you know, I don't want to call it until the end. We saw that you don't want to call a winner until, what is it the saying, until the fat lady sings or whatever, because things can change last minute, like they did, for example, in 2016. So don't want to call a winner until everything is over. So we'll wait until it finishes. I should shave my head. Oh, no, I'm not going to shave my head. Whose wife? We can make you stream your haircut. No, I'm gonna do it by hand. I'm gonna use scissor cuts probably. Cause I don't want to make it that short, like military buzz cut. But in the meantime, Let's do puppy. It's over now. There's not enough viewers to swing the vote. Yeah. It seems like there's a winner. We have a 79%, 22 against 6. So that means we got 28 active viewers, even though there's 36 viewers. So other ones were scared. Or maybe they're not logged in. I don't know. Channel points to see Padme. No, because if she's not here, then I don't want to bother her. So, can we choose about which one to take? No, I want to be consistent. No, we cannot do a vote to get rid of assignment 12. Okay, I'll leave her alone. Negative. I can't do that. I'm not allowed to replace the final with the project. Not part of. There are certain rules for 302 that are meant for your protection that you can't do. And that's one of them. Okay. All right. Poll's over. The winners have it. The test will not be comprehensive. It will only be based on anything that was not in the second test, which, if I am recalling correctly, is literally everything from graphs. I will check again, but I'm pretty sure that the everything except graphs isn't. So the test will have. We'll talk more about it on Tuesday, but you can expect it to have the algorithms from the graph stuff and nothing else. Okay. All right. So now, the best time of the class has come. I'm gonna launch the VM and I'm gonna show you the final project. So let me tell you a story about how my life got flipped, turned upside down. I forgot the rest of the song. The virtual machine is launching. So I'll tell you a story. That wasn't the Fresh Prince. Oh my gosh, what happened? Okay. Skynet took over here. Okay. So there was an idea in spring, or shall I say fall. What are we? What is it? So right now we're in fall. No, we're in spring. So fall. Fall will be last semester. Yeah. Okay. There was an idea in fall of 2018, and that was to make an assignment for CS 135 based on a video game that was popular at the time. That was Fortnite. And so that time, for 135, the original Battle Royale assignment was born. And the Battle Royale assignment was an assignment where people had to walk around the map, and there was a storm. And in 135, there was no movement, actually. You just spawned a bunch of objects. Not objects, because it was CS 135, so they were just cars. And then the storm would enclose, and the last one that was left alive after the random storm would be the winner. And that's where it ended there. Or at least for them, that's where it ended. But not for myself. Because the following semester, in spring of 2019, that idea grew into what would be a 3-phase project for CS202, which was the infamous Battle Royale assignment that one of your students came in to present to 2 of the 3 classes at the beginning of the semester. That was sections 1001 and 2. That Battle Royale assignment was, there is indeed a legacy to this. That Battle Royale assignment was quite impressive. There was movements, but you could shoot other players, you could move around. The AI though was static, and that was pretty much it. But I switched it from an array assignment to basically an OOP assignment. And it was very, very cool. You can ask Aisawa and some other people that were there how that went, but I think you got to see the presentation. From there, the Battle Royale assignment lay dormant last semester, as instead 2019 fall was a semester of inception, a great assignment of its own. But the Battle Royale assignment trilogy had to come to an end. And so this semester, the Battle Royale assignment has transcended into the next most amazing project, and frankly, the best program and the best assignment in general that I've ever done. And I'm not gonna lie, I think you guys this semester, and also two last semester, which a lot of you are coming from that, are the best set of programmers that I've ever had the pleasure of teaching. And because of that, I have no doubt in my mind that if I was to give this assignment to anybody, it would be to you guys, that you can actually get it done. And that is why I'm giving it to you guys, because I know that you can get this done. And so now, the final trilogy of the Battle Royale assignment is not actually Battle Royale, but instead, you are going to be coding a video game indeed that has a lot of the functionality from Battle Royale, but in a much more cool and much more popular game nowadays. And that is Valorant and Csgo, because you will be coding a 2D version, a fully functioning 2D version of Counter-Strike Global Offensive in 2 weeks. And because Valorant and Csgo are essentially the same thing, bomb planting and things like that, you will be doing it. And it is going to be amazing. And so, let's just jump right in and show you a little bit of what I've developed. It's not done yet, but it will be within the next day or so. All right, so here's the code so far. 671 lines of code. I expect it to be under 1,000 when it's done. Let me just summarize some of the features of Csgo or Valorant. So with Valorant, the objective of the game is to plant a bomb. And the objective of the other team is to defuse the bomb if it gets planted or not let them plant it. So you are going to be coding a map where players, you can move around, pick up a bomb, plant the bomb, shoot other players. You will have an AI that can do the same thing, a fully functioning AI. And if you played CSGO, you know that the AI is really dumb. Your AI is going to be way smarter than the one in CSGO because it's going to have shortest path, which can be used for both going to the bomb, going to the bomb sites, and finding enemies and line of sight shooting those enemies. And so everything CSGO and Valorant works, you will have. The two things that you will not have that CSGO and Valorant have is multiplayer online. I'm not going to make you do netcode to make it work online. It'll just be offline AI. So you and other 9 AIs, and there's no economy. And there's only one gun. You just shoot. There's no economy like there are in those games to buy guns and things like that. Okay? And the shortest path part is going to be, of course, for the AI to actually work, which is, frankly, the only thing that was missing in the Battle Royale assignment. All right? And so, let's go ahead and run and give you a little walkthrough of what I have so far. The input file, as you well all aware with the teaser, is actually going to be the, in fact, let's go ahead and look at the input file first. So I will do more that. I did this by hand, and I will offer a little bit of extra credit. I haven't decided how much, but I'll maybe like 50 points, 50 homework points or something. To those of you that want to develop more maps like this, to make an ASCII thing for the map, so that we can have so that we can have more levels to play with. So this is something that I coded by hand. This thing right here. In fact, maybe I can. Can I zoom in a little bit? I don't know if I can zoom in, but you can see it, right? I can probably. Yeah, you can see it. It's okay. I'm sure you can see it. These are just a bunch of characters, right? So this is actually the input file. This is a text file, okay? This is Dust2, but I want more than just Dust2 because our game, the AI is going to be so smart that it doesn't matter what map you feed it, it will know how to actually progress it and play it. And so if you can come up with some Valorant levels and CS:GO levels, it's gonna be lit. So I want to see more than just Dust2, but if not, Dust2 is life, Dust2 is love. So okay. So that's just the input file, okay? So that input file is fed into the assignment, which is using Cursors library. So let's compile it. Let's run it and watch it crash, no? The game starts and it asks you, welcome to Counter-Strike Valorant Offensive. That way there's no copyright infringement. Press any key to begin your journey into a world full of imagination. So I press a key and now it asks me to select a team. Would you like to be C or T? I'm going to start with T. So I press T for T. Terrorist team selected. And by the way, because Csgo is a esport team at UNLV, I believe, then it's perfectly valid for us to have that as a subject. It's not inappropriate. So you can't use it as an excuse not to do the assignment. So, okay. And now the game is on. Right now I don't have a synchronous input going. I don't know yet if I'm going to require you to do that. If I do, I will go ahead and give you some of that code. So that means that the only way that the game refreshes is if I press a key. So I can use my WASD or my arrow keys, but I'm going to use WASD. The at symbol that you see is me moving around. I cannot go through walls. As you can see, it stops automatically. Those flickers, I don't know why they flicker sometimes. It's a bug. Don't worry, we'll fix it. But I can pick up the bomb. There's also a time at the top left. You can kind of see counting down. Let me see if I can make this a little bit bigger for you. Give me 1 second. Duplicate Twitch chat 22. Okay, and now yeah, okay, that's a little better. Okay, that's a little better. Okay. They do have a CSGO team. Yeah, if you have no clip on, then I was thinking about it as a debug feature. But okay. All right. And so you can see at the top there's a timer, right? Right now, because it's not asynchronous, to progress a timer is a click basically. How many clicks do you have before you lose the game? And right now the AI is offline because I haven't finished doing that. So the AI is just standing still. That's T's and C's. They all spawn at the same spot. Okay? And so the B is the bomb. So I just picked up the bomb. Now I'm carrying the bomb. So now I'm going to go ahead and take it to B because, you know, rush B, right? Anything that's P is a plant site. The moment I go in there, it'll automatically plant the bomb. Gives me a little message there, bomb has been planted. Says up there, and the timer, 30 seconds. Now, if CT was there, they could go to the bomb and defuse it. Now, here's the thing that I just found out right now, this little second, that I think I should do. The bomb is not showing because the plant site has higher priority. I need to go ahead and fix that so that bomb shows higher. Because right now the bomb is like, I don't see where the bomb is. It just disappeared, but it's been planted. So I'll fix that. Bugs, right? Just like a real game, there's bugs. Anyways, if I just let the time run out, 7, 6, 5, 4, 3, 2, 1, terrorists win. And that's pretty much GG easy, end of game. Let's run it one more time. This time, let's play Counter-Strike. Counter-Terrorist. As you can see, I can move around, and if I was to let the time run out, it'll run out. Also, this was really tricky for a second. Like, I actually had to think about this for a while, but implementing was easy. How do I get the bridge tunnel working in 2D? And so the best thing that I found out to do is the pound symbol is a tunnel or a bridge. And when you enter it, you can only go in that direction. You can't go up and down if you enter left and right. And that actually was the best way to, and only way that I could think of getting that working without doing nasty things for now. But once I implement the AI stuff, I might be able to get around fixing that. And so as you can see, that's how that works. And so if I let the timer run out, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, counter-terrorists win. GG easy. So what do we have here on the chat? No explosion. Yeah. I should add an explosion. Yeah, that's a good point. I'll add an explosion then. That'll be cool. But you got, then you guys will add it too. Can you give us the keys so that we can make our own maps? Yeah, of course. I mean, there's nothing to the keys other than like X's are... The X's are the walls. And it's basically a wall, but I thought of making it like a null to save memory, but I haven't implemented that yet. So right now I'm just using all memory, but they're basically walls. The empty, the random spaces is just walkable space. The O is an obstacle that you can shoot through. So there's no cover in this, but you cannot walk through. P is anywhere where you can plant the bomb. And T stands for the T spawn and C stands for the CT spawn. If I move, that's why the A was the C, because I'm a counter-terrorist. And then when the players move around, they actually all say C's and T's. That's the only keys. If you scroll down in the input file, which is basically the thing that I have here in the code, it tells you what they all are. Pound is tunnels and bridges. So that those are only spots where you can move in the same direction you came into them. So you can't change directions in them. And then wall obstacles. B is for bomb, so where you want the bomb to originally spawn, because in Valorant you don't spawn with the bomb, so I wanted to mimic that idea. I think it's smarter than Csgo's. Give the bomb to an AFK player who just trolls, and then have to code in a thing where it drops the bomb after 30 seconds. I didn't want to do that. P is for plannable area. Add is for the player. I just make the player spawn based on wherever the C and T spawn. So that's not used in. 1 and 2, I don't quite use that. It's just to indicate the bomb site name, but I haven't used it. I just replaced it with a P. And then gun drops, I haven't put that in yet because there's no gun drops. You just, if you die, you drop the gun. But because there's only one gun right now, I'm just not dropping the guns. They're just disappearing. So yeah. Could you store the overpasses at a different location with its own collisions? I don't know. You could once you do the graph for this, but right now this was the easiest implementation without the graph side. It's not 2 layers. It's literally 1 layer right now as I have it. Things will get wonky once the AI starts shooting each other with that. You should be hyped. This is pretty awesome, and this was pretty tricky to kind of get going. But once you get going, it's quite trivial. Let's see. Will the second function be done, or will we have to code every component beside the map? You have to code everything, unless I give you more than the skeleton code that I'm giving you right now. Can you keep scrolling so I can see more? Heck no. Just enable team killing, so you can grab the one from AFK. You know, I am tempted to add team killing in, because then I want to see if the AI accidentally kills each other. That would be great. So I am going to make the projectiles damage anything that they hit. Can I use aimbot? Only if you have a skeet invite. I'm pretty happy. This will be definitely the coolest thing I've ever coded. I mean, it was pretty much the coolest thing I ever coded for an assignment myself. And so here, let me show you, because somebody did buy the 1,000 point skeleton key code. Let me show you what kind of skeleton code I have so far. Okay? And really, my skeleton code I'm giving you, I will call this skeleton code light, because it's not really much. So let me pop that open right now. I'm clicking on the video instead of the actual thing. So this is the skeleton code light. Okay? And I call the skeleton code light because it's only 96 lines of code, but it is useful to kind of get a feel for using the end cursors library if you didn't use it already when you were doing the Omega Watch. The end cursors library, by the way, the reason I'm using it is because it makes key input so much easier, and it makes refreshing the screen so much easier. And you can actually add color and other really cool things, which I haven't added yet, but I might add in to just make it nicer. So anyways, how does end cursors library work? You don't need to know. So I'll give you the short version, I'll give you the long version. The short version is, instead of using printf, which is a C way of printing, you use print doubly. And that's pretty much it. That's all you need to know as far as the assignment goes. Maybe you also want to know the function clear clears the screen, and the function refresh refreshes the screen, which I think there's a bug going on because it flickers sometimes. So what I have in the skeleton code here for you is I have a main function, and then I have a class called carmap, and that class carmap is meant to read in the file. That's the map file. and read it into a 2D array of cars, which you can then process and create another 2D array of the actual map itself, which is made up of a bunch of entities and things like that. How many points is this out of? Oh, good question. Big question. Oh, the tablet shut off. Hold on. Rip. Hold on a second. There we go. So, are you guys ready to find out how many points this is out of? Here's a digit. Here's another digit. Here's another digit. And there's that big digit. It's 1,551 points. That is going to be how many points the final project is. There's something nice looking about that number. All right. So you can't say that I'm not helping you, because if you do good on this project, you can boost your grade if you haven't done so good so far. All you gotta do is do good on this. And yes, this is a palindrome. So it's very poetic. It's just a palindrome. There's no meaning to the number other than that. The absolute value of 55. I don't think it's a reference to anything. No, it was just a number that I came up with as I was trying to fall asleep. And I thought it was a good number because the other number was 777, and I think this is worth almost twice those points. So here you go. Hype. So hopefully I haven't missed up any other questions. But anyways, let me go ahead and finish walking you through the skeleton code that you're getting. So this car map is going to read into this array the input file. And the input file is always made up of the following. In the beginning of the file, let me go ahead and... Oh, you can press Q to quit, by the way. I added that feature. Because Ellen Curse's library, if you don't quit it normally, you can't Control C out of it. And none of that is like memory leaks or terminal. Bad things happen. So you want to make sure the first thing you code in is a way to quit the game. So let's go ahead and open up the input file again. More SJF. The first line of the input file should be the name of the map as a single non-spaced out key of or a group of letters. So like dust_2. If you put a space there, it breaks. So don't do that. The next is going to be a number, which is going to be your height of the map, and then an X, a space, and the X, a space, and then the width of the map. Put that in like that, and then the computer. And I mean, you don't have to have that. I could have used like SSStream and other things to figure those numbers on the run. But I was like, why do more code than I have to when I can just put the numbers in there and not have to spend a bunch of time doing SStream and all those things? There's some restrictions to using the Ncurses library. I thought already doesn't work well in certain conditions somewhere on Discord. No, what happens is this. Ncurses is a Linux library. I believe it also works in Mac, but it does not work on Windows. If you want to use it on Windows, which I warn you in 202 and in 302 that you can't use Windows in this class, but if you've survived this far on using Windows, you have two options for this. Option one is Sally Life. Option two, I believe there are libraries that mimic Conio in Windows. Mimic curses in Windows. One of those is conio.h. The other one is PD curses. Your best bet is to go in and try those out. But I can't give you any support on that because I don't know myself. So you're on your own on that side. Good luck. Good luck. I'll try to help you, but I mean, I have a Windows machine. I can experiment, but I don't know what else to tell you on that other than you can use a define and do a cout version of this and then switch it to curses afterwards. I mean, in theory, you could do this with just cout. You're just gonna have a painful time trying to get this to erase. Because I mean, the first time we did the Battle Royale assignment in CS 135, I used all couts. And I have the code for that. I was going to show it to you. So it is possible to do it. It's just really, 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 really annoying because reading the keyboard input doesn't work too well. So, yes. So yeah, if you got it working with the watch face, you can get it working for this. So there you go. And if that's the case, then you don't have to use the end cursors library. Yeah, you know, you don't have to. So there's freedom in that. But if you choose to use it, let me tell you how to use it. There's two functions in the skeleton code that they're called Initialize Cursors and End Cursors. They take care of doing everything required to get the cursors running. Just copy and paste them in your code. Read the details if you want to know more about them, but that's all you really got to do for that. Once you got those functions in there in your main, you will see that I call init cursors here and I call end cursors at the end. Big thing about cursors, do not, and I emphasize, do not mix end cursors with cin and cout or printf and get and other get functions. They don't like that. Things break. It's not because I don't want you to do it. Things break and crash. Like you randomly segfold in the middle of nowhere because of it. So once you commit to cursors, you go all the way. Otherwise, you stick with cin and cout, but don't mix and match because then you get random crashes. It's not me trying to be pedantic about not mixing and matching libraries. It's more like if you mix them, you get crashes, and then you complain like, "Hey, things are crashing," and I'm like, "Did you mix them?" No, that's probably why. Cout takes time to print, so unless you print a full screen with one cout, it's gonna flicker. I mean, even end cursors flicker sometimes, so I don't know. Some weird things are happening. But then again, it's a game. Games have bugs. As you can see, there's tons of memory leaks in games. Now you will experience that side of coding. And I'm excited and I look forward to helping you guys do this. This barely flickers right now though, so I'm kind of happy about that. My CPU goes kind of crazy when I'm running it sometimes. So I don't know why. I think it's just a bunch of memory leaks from having end cursors not closed before, and I haven't restarted the BM in a couple of months. Can we have memory leaks? You know, just like real games. Let's put it to you this way. I will accept a certain degree of memory leaks in your program, but if those memory leaks grow to something unacceptable, then I will not accept it per se. My CPU utilization right now is kind of like at 80%, but that's also because I'm streaming. So I will accept a certain degree of memory leaks in this assignment. I'll put it to you that way. Just because like right now, I mean, heck, let's run Battleground and see. I think I fixed that one memory leak that I had. I posted on Discord. Valgrind./a.out. Okay, I gotta let the program run all the way. Actually, here I think. Whoa! It's like lagging. It was lagging for a second. I was pushing stuff and it was not reacting. Look! It's like lag. See that? There's like a delay. Battleground cannot handle the game. So there's a delay in the output. Oh, that's kind of cool. You don't see that in normal game. You just on Battleground. Oh, that's amazing. Wholesome experience right there. Let's see. Battleground said 13 blocks lost, 46 indirectly lost, no possibly lost, and still reachable. It's not too bad. That's like I would say that's. I mean, okay, the indirect loss is kind of high. I'm going to look into that. But the definitely lost, I'd say that's acceptable. This is real cutting blocks and all. All right. 194 errors. Are there? From one context. It's just one thing that's causing errors. I haven't gone and added all my delete functions. So that's probably why. So yes. Let's push this into production tomorrow at 5 p.m. That's probably what will happen. I'm going to release the PDF at 5 p.m. tomorrow, and it's going to be like, production code, guys. So anyways, back to the LN Cursors library. The LN Cursors library doesn't have memory leaks, but it does have still reachable memory. So that's probably where that still reachable is partially coming from. The biggest thing is how to print things in cursors. And that, again, it works the same way as printf works in C, which you can just Google printf. And I talked about it in class that one day, but you can basically repress the F with the W, and you got print W. Again, don't mix them. Bad things happen. And yeah, this little code. I mean, if I run the skeleton code right now, here, let's run the skeleton code. That's probably because oh yeah, when you compile with ln cursors, you need to add ln cursors as a flag, okay, like that. Otherwise, it will not compile and it will give you those errors. Oh yeah, I did error checking. If you don't pass it the input file, it gives you an error. So that's just the skeleton code. It's gonna print that out for you. As you can see, it almost looks like the game version, but this is just it's just printing a 2D array of cars. The other one is not printing this at all. The other one deals with the input file into that map array and then converts that map array into all objects, baby, everything. But at least this gets you far enough into actually seeing something happen. This is just, you know, that's it. So that's your skeleton code. So I will publish. I mean, in fact, I'm gonna copy and paste that into Discord as soon as like I finish the stream. I'll push that version into Discord, and then I will continue working on it tonight and tomorrow. I have to do one thing. I have to do this bio sketch thing for a proposal that I will do as soon as the video lecture ends. That will take me maybe 2-3 hours. If I'm not dead by then, because I haven't really slept, I will finish the code. If not, I'll go to sleep and then I'll wake up at like 2 a.m. and then I'll grind it out and finish it. Because I'm so hyped. Like I did nothing yesterday but code this. Like literally from wake up time to sleep time, I've been coding this for the past 2 days. So actually, no. Yesterday, it was like that for the first day of the coding. The second day of the coding was morning to night. The day before, it was like the second half of the day, to be fair. So I've spent about anywhere from 16 to 20 hours on this code. Maybe 24. But that's because, again, I was doing it from scratch. It should not take you that long. I've spent about the same amount of time in the inception code. So I think it's comparable in terms of, at least in my development time for making this. So I noticed in the skeleton code, there's only one position where say your code here. Is that only where we have to put new code? Well, technically, the way that I set up the skeleton code, you really only have to you don't have to mess with anything else in main, as long as you code there, and then of course add your classes there. But that was more of like just in this case, it's more of a direction. You're free to do whatever you want. You don't even have to use my skeleton code. So in this case, your code here can be anywhere in the code. It's just that, like, actually, good question. When did I create this? Wednesday at 10:36 a.m. Oh, there you go. That's not too bad. So that means I really only spent, so look, from here, from this version to the other version that you're seeing now, that's development time maybe, so from 10 a.m. But I did take like a 4 or 5 hour nap in the middle of the day. And then I stopped at 6 a.m. or 7 a.m. today. So that will be 24 hours minus 3 hours, 21 hours minus the nap. Maybe the nap was 5 hours long. 16 hours. 16 hours of development time from what you're getting of the skeleton code to where I'm at right now. And I expect to spend maybe another 5 to 10 hours to finish the code. Total development time under 30 hours. For me. For you, I would say half of that time, because you know what you're going to do. I'm going to describe all the classes and everything to you. You're supposed to code the AIs. Yes. And that's what I will be doing. That's what the Dijkstra part is going to come in. This is what you're getting. This skeleton code that I have right now is what you're getting. Yes, the pathfinding and the actual AI. But that's easier than you think. That's a much easier problem than you think. Frankly, I will try to give you a detailed PDF, but I think it would be much better for me to actually walk you through the classes by voice, because otherwise then you will be clueless. So let's go ahead and do that right now really fast. Of course, to do that, I'm going to have to hide the code from you guys. So no code for you. And now, reminiscent the fact that behind this screen, I am looking at code. So I'm going to walk you really fast through some of the things that I have so far, and subject to change. If I find bugs that I can't fix without changing something and refactoring code. But each character on the map is going to be a node indeed. However, this is the part where you really only really need to have nodes that are a space or a P, which is plantable site. There's no point in having a wall as a node because no edges are going to be connecting to it because you cannot go into a wall. So really, I'd say your graph is only made up of the white spaces. Maybe the walls, but not necessarily. Okay? That's just the way that the pathfinding will be much easily done. Again, that's the part that I have to finish, but I don't think it. I mean, I think I've done the hard part, to be honest with you. The rest of it I find to be piece of cake. Everything is easy. It's just time consuming. Some of it, figuring out how to do things or the others. Some of this stuff was coming right out Battle Royale, so I knew ahead of time how to jump in to do some of these things, and it wasn't coming off of with a brand new mindset of how am I going to code this from scratch kind of thing. I kind of had an idea of, all right, I need to have an entity class that's a super class, and then have virtual functions that define what this is, and then derive that into the subclasses. So everything. So I guess this makes sense when I start talking about it. Let me talk about it. All right, the heart of the project of the code is your entity class. This entity class is your super class. That entity class has an ID, and that ID is going to come in useful because you can manage things a lot easier when you have an ID. Okay, and so in this ID. It will be unique. It'll be like the elevator assignment in 202 where it has to use a static variable, and so everything has an ID. Okay, so this entity class has a function called has coordinates. So every entity, I found it much easier. It wasn't necessary, but it's just way much easier that each entity maintains its own coordinates of where it exists. Now that I remember that, I need to make sure I actually did that for the bomb itself. So I'll go and check that later, actually. But because the bomb is derived from the entity class. So the entity knows where it's at and its ID. From that entity class, we can derive a couple of things. Bomb is the first one. I have a bomb class. That bomb class defines the virtual function of entity called what am I into just returning a character B, which identifies it as a bomb class. So that then you can dynamically cast that entity into a bomb class. And so there's a couple of variables there, which are, am I planted? Am I being carried? Am I diffused? Those, of course, are useful to know the status of the game. So like if the bomb is planted, if it is, then I can go ahead and start the timer, and I cannot pick up a bomb that's planted already. I have to defuse it. Is carried, of course, is useful so that I know that the bomb is not on the floor, so it's not non-pickable. Somebody's currently carrying it. And this diffuse is a game-winning situation. All right, player T, that's a big class. That's where your AI stuff is gonna come in, okay? Player T has a couple of things. It has a couple of variables that ask, one of them is, it's a Boolean variable whether you're human or not. Useful so I can identify AIs versus human characters. They're all human, but what I'm saying is a playable character versus an AI character, okay? I have a bomb pointer in my player class. That bomb pointer is set to null unless I'm carrying the bomb. If I'm carrying the bomb, I assign that pointer to the bomb object. It's a very elegant solution to be able to carry a bomb, basically. I have a last direction character here, local variable, which class variable, because that helps me with the tunnels. So it remembers which way I was facing when I came into a tunnel, so I can't turn into the tunnel, which is how I kind of, my only solution so far to create a tunnel in a 2D map. Okay? And yeah, no, I mean, you're gonna get a PDF, don't get me wrong, but you're still gonna, you're not gonna get the same level of knowledge that you would get from me talking about it, because there's just no way I can, I mean, I could literally just, everything I'm saying, I could put on the PDF, but you're still gonna have questions at the end of the day. Nothing about that. This is being recorded, yes, of course. That's the point. You can rewatch this later, so you can finish here in the descriptions. Yeah, I'll drink some water. There, I drank enough water. You're gonna kill me here. I'll give give some to my dog. We got a status marker to show whether it's dead or alive. If you gotta go, that's fine. You gotta go. Just watch this later when you're actually starting to code the assignment. Yeah, you guys are toxic. You know, you could have saved your points for another skeleton code that could be released if it required like 5,000 points, but y'all got scammed. Lol. Saving up for that dab, that's right. Okay. Set team, there's a team, so you can pick it, so the player has a team assigned to it, and whether you're carrying the bomb, which returns whether the bomb pointer is null. Okay? Then the other big class is point class. The point class is going to be a single grid point in your map, which can contain, if you look at the class variables of point, the big one is it contains a vector. Yes, I'm using vectors because it made it easier. It contains a vector of entities, and actually a vector of entity pointers. That vector is where I just throw everything in that's currently residing in that point. If you have 5 players in the same point, such as when you spawn, or you got potentially, worst case scenario, you could have all 10 players are in the same point for some reason. The bomb is there. It also happens to be a plannable spot in the map, and maybe there's some drops. If everything is literally on the same spot, then in theory, all of that could be in that vector. Nice memes. So, anyways, that's gonna be that's where you're gonna spend some time on getting that running probably. There's also a couple of booleans in endpoint, which are whether it's bomb side, it's obstacle, it's wall, or it's tunnel. Those define based on your input file what kind of point you're on. If it's a wall, if it's something that's just empty space, if it's a plannable space in the map, if it's a tunnel, so you can only go in one direction. That is important. Those things define what this object is and how it affects player movement and other things like bullet trajectory and things like that. Because of that, I do want to have a base type for the point. And your base type is typically going to be either an empty spot, which means it's freely to walk around, an obstacle, a wall, or a null. Which again, I haven't really implemented a way of saving memory using null. I might do that, I might not. We'll find out. It's one of those, it's kind of like real development, you know. It's at the end of the list, which means it's probably never going to get to it, but it's something that actually would improve the efficiency of the game. But hey, let's add features over fixing our code, just like a real game. So yeah, there are also coordinates to remember where this point is as well. Okay, and the big functions here are of course render point, which you have to do some logic, which I have to fix here, so you can render the most important thing in the point always. So if you have a point where that is also plannable, but you also have a player that can be there, then you want to render the player on the top of everything because that's more important. If you have a plant site and you plant the bomb, you want to render the bomb versus the plant site, which is what I have broken right now. Ultimately, it's about, you only have one character to render. So you got to pick, if there's more than one thing you can render, you got to pick the most important one. And I will put in the PDF the priority, which is basically the most priority or the highest priority of what you want to render is the real player, you, because you want to be able to see where you're at in the game. Second priority is the AI. Third priority is the bomb. Fourth priority is whether the site is plantable or not. And then that's it. The fifth priority is just an empty spot, basically. You don't want to render an empty spot if there's stuff there, because then you don't see it as like invisible. Trust me, to get to this, lots of things have to be patched together to get a wound. So that's a big function, render point. The other big function is the constructor actually, which is setting everything up. So yeah, basically initializing it based on the input file, which in this case is not the input file, but is the map class. That is what you get in your skeleton code. Okay, then we get to the other big time class, and that is going to be the class called level. That's your world, that's your meta, the big class that controls everything per se, or at least contains everything. In main, you just declare a level, that's all you do, and it contains everything else. Everything, points, players, entities, all that stuff is contained within level. Each level is an object. That's it. One single object. Because of that, level is the one that's actually going to generate the 2D array of points based on the 2D character array map. That's in the constructor, actually. There's also a function called render level, which basically calls render point for every point, which render point I talked about earlier. Clear screen is just a, refresh, basically. I'm not going to talk about it too much. Big function here is called open and team select. That has all your introduction. They're like, welcome to the Valorant game, and select your team and things like that. And when you select team, you have to actually create the player you're playing with, assign it to the team based on what you select, and at that point you've already generated 5 AIs on each team. So what you will do is you would remove one of those AIs you did, which I don't think I actually deleted, so they're memory leak right there probably, and then replace it with you. I was thinking of adding a third option, which is to select team 0 per se, which means let the game play itself, because that might be cool to see instead of so all AIs basically playing. Just like in Csgo, there used to be that tournament where it was AI versus AIs, and it was like a comedy basically, because they were like really dumb AIs, and you got a bunch of views. I remember that. Good memes. So yeah, that's open and team select. Lots of logic happening there to get that going. Lots of pain that I had to go to get that going, I'd say. But now that I figured out how to do it, I'll describe the basic process of doing that. Okay, that's a really good question. Yes, if you just set the thing to go for the most efficient path, the game would be the same game every single time you played it. Like the AI would literally do the same path. It'd be kind of boring. Which is why, in addition to doing just Dijkstra basically, once you have the shortest path and whatever, you're going to add a percentage error. And I was thinking of doing that in the command line arguments. Like anywhere, a number from 0 to 100, which represents a percentage. And that will tell you how often the AI makes a mistake. And instead of moving in one direction, which is the correct way, it moves in the wrong direction. And that should add a certain level of randomization, which will make it more natural and will not make the same gate every single time. And the AI has priorities. T wants to plant a bomb. However, CT needs to defend the site. So it will make it random 50% on which side it goes to. If it goes to defend the A side or defends the B side, and then it just picks a spot on the site at random. And so adding all these little random elements to it should make the game more natural instead of just like, oh, they all just go there and that's it. That should hopefully make it more interesting. These are the things that I will be spending my day on tomorrow. And once I come up with a good set of randomization that is useful and interesting, then I'll tell you that's the ones you got to do. Because I don't know, maybe some things that I'm thinking will work really great, and other ones will not. I'll find out tomorrow. But I think there's enough of the assignment already done for you to get going on before you even start adding all the AI. The AI will be the last step you should be working on, to be honest with you. Check round status. That checks whether the game is over or not, based on a couple of conditions. The basic ones are: condition 0 means it's not over. Condition 1 means bomb defused. Condition 2, bomb exploded. Condition 3, CT is dead. Condition 4, T is dead and bomb is not planted. And condition 5, time is up and bomb is not planted. And depending on one of those, which condition you go in is what team wins, basically. As you can see, I have working timers now. Finally, we get to the other big class. And this class, I might move it around and make it part of another class. I don't know. It's just kind of a class that's just floating there. I've only talked about 380 lines of code so far. So it's just, I'm trying to be very descriptive. It's called a movement dispatcher. And that movement dispatcher handles all the player movements. And eventually the projectile movements as well. You have a function called make move, which based on a direction that you're already given. So maybe let me talk about the other one first. I have a movement dispatcher read input key. It actually reads the key you press using the Cursors library, parses it into a specific character that indicates up, down, left, and right. I was going to have diagonal movements, but I decided not to because that'd be weird. Usually in diagonal movements, you just press 2 keys And so if I can't really do that here, so I was like, I'm gonna make weird things happen. I got rid of that feature. So read key is gonna parse the key and then it's gonna feed it into make move. Make move is gonna take that direction. It's going to check where you're at and where you want to move to, and I'm gonna check whether you are legally allowed to move there or not. Meaning, is that a spot that you can move, as in it's not a wall or an obstacle or something else that's blocking you there. And if it's not, then it lets you move there. And when you move, the way you move is you are an entity that is stored in the end list of the point. You're going to be taken out from there, and then you're going to put into the new entity list for the new point using the vector. So the erase function and the push back function. When you do that move, then you also have to update yourself to know that you move by changing your X and Y values. So there's logic that you have to follow to make sure everything goes smoothly. Don't worry, I'll list it on the PDF, but you basically have to make sure that you do this in the right steps. Here's an example of a bug that happened. I forgot to update myself that I had moved, even though I had actually physically moved in the map. So the next time that I tried to move, it was using the old direction of where I was, so I was never moving. I was just like bugging back and forth. And I was like, huh? And it's like, oh, I forgot to change the direction. And then once I did that, everything started working with the movement, right? So, yeah. You also want you want to check here if you're legally allowed to move into the tunnel, because you can only move in one direction based on the way that you came in, and so on. And then once you're finished moving, you want to call the post movement check, which is the other function in movement dispatcher. And that one is once you move and you land in a new spot, there's a couple of things you want to check. For example, if the new spot you landed on, the bomb happens to be there and you're a terrorist player, you can pick up the bomb at that point. It automatically picks up the bomb. The other thing is, and I could have made this harder, but I was like, screw it, is if you're on a plant site and you're a terrorist and you're carrying the bomb, you automatically plant it. Vice versa, if you're a counter-terrorist and you stand on top of the bomb and it's been planted, then you defuse it. What you don't want, and this is part of the if statement check, is if you're a counter-terrorist team, you want to pick up the bomb, because only the terrorist team can pick up the bomb. Same thing in Valorant. I'm just saying CSGO because that's what I'm more familiar with. But yeah, so there's some checks that you do once you land there. If you pick up and then if I add gun drops, which I might do, I don't know yet, then you could also auto pick up a gun. But at this point, I only have one gun, so there's no point in adding it. And I think that's just too much work at this point to add the extra guns. But we'll see. Anyways, that pretty much concludes everything with exception of main. There's of course the init and cursors library, which is in the skeleton code. My main, as you can see in the skeleton code, and then in this version, my main is from 390 to 315, so it's like 25 lines of code. Pretty small main. Easy. I just read in the map from the input file, initialize cursors, create my map, create my player, and go in the main game loop. The main game loop is like 6 lines of code. It's gonna add like maybe 2 or 4 more lines once I add the AI. But basically every time I'm looping, I'm reading key input, and then I'm parsing that by calling the make move function, so I can move if necessary. In there, I'm of course going to add in a AI mover. So every time you move once, the AI is going to move once as well. All the AI. And at least until I add asynchronous input, which I may not add because I don't think at this point we have enough time to do that, then you have to move for the AI to move. So it's kind of weird like that. If you feel like adding asynchronous input, which I might give extra credit for, then you can do that. And so the AI can move freely without you moving, which means without you pressing keys. And then basically every round or every tick per se, I clear the screen and re-render it after everything has moved around, because you move, you want to re-render with the new location and things like that. And then I also check the round status. So if the bomb was defused or the time ran out, that kind of thing. So I call it the check round status function. And then of course I have my deletes, and that's it. That's the end. Yes, like super hot. That's a very good example of that. Right now it's like super hot. Exactly. I love that example. Yeah. Super hot VR. Yes. Where if you don't move, the game doesn't move. That's pretty much, yeah, that's amazing example actually. I gotta remember that. Yeah. All right. So now let's see what comments we got. If AI follows same pathfinding with all 5, okay, we said that already. This project is like that guy at the gym that screams when he lifts extra. The Brad, I'm telling you, you're gonna have so much fun doing this project. You're not gonna feel annoyed at the work. You're gonna be happy. And trust me, when you finish this and you figure out you literally coded CSGO in 2D. At this point, if I was in control of giving you diplomas, I would give you your CS degree and be like, you're ready to go out there and do whatever you want because you're a good programmer at this point. So that's my thing. And for that, I am announcing that just like last semester, assuming we ever come back from the COVID-19 situation, the first 3 people to submit the assignment will receive one of the Raspberry Pis, just like you did last semester. So first 3 people to submit an assignment that is working 100% will get a Raspberry Pi. So if you want to be one of those winners, get started on it, get it done quickly, submit it, and you're good to go. Disclaimer, I think the people, if Linter's around, he can tell you. I think it's like a Raspberry Pi 1B or something. It's not, I don't think it's one of the new ones. But hey, it's a Raspberry Pi. You can even see the Raspberry Pi can handle, you can even like save your CSGO game on the Raspberry Pi. Get one of those like super cheap controllers, bind it to the keys, and then take it anywhere and show anybody your CSGO game on your Raspberry Pi. How cool would that be? Like, that would be so cool. So, anyways, as we talked about, one of the things that I am doing to help ease the fact that you have to do the project is, of course, non-comprehensive final. But yes, playing CSGO with a controller. I know. It's blasphemy. But I'm just saying, the 2D version, okay? I mean, there's a bunch of people that probably play Call of Duty with a controller, so. Hey, we'll add aim assist. It's okay. We'll be good to go. Aim assist solves everything, right? Don't play with a controller. Don't be that guy. It's like, imagine playing with a controller. My dog looked at me like, what the heck? All right, then. I'm out too as well. I have finished. I'm super, super excited for this. I hope that you guys are too. I'm going to post on Discord the skeleton code that I have so far. And then the rest will go on the PDF once I finish that tomorrow. Thank you for watching. Let me minimize the code before I accidentally leak that out. I am down to play Valorant, but I have to do the proposal thing first, and then I'm probably gonna pass that afterwards. But otherwise, I would love to play Valorant. Valorant is love. Valorant is life. This is the throne room for now. It's like at last I have shown you what the true power of programming can do. All right, everybody. Well, we will talk more about the assignment on Tuesday, and I'm sure you'll hear about it all over Discord this weekend. It is a competition, so the timer starts now. Even though I haven't posted the skeleton code, you could technically implement it by hand right now. Can you get a recipe from playing Valorant? Only if you're playing in the implementation of your assignment 12, and you're the first one to turn it in. And then, yes, you would get a Raspberry Pi playing Valorant, technically. All right, then, everybody. We still got 26 viewers, so people are not that scared, I think. I'm super excited. I know you guys can do it. I know it seems like a lot. That's because you've never done anything like it, probably. Once you get done, you're going to be like, GG, easy. If you haven't done 11, then I am concerned at this point. You better get going on that. Because this thing is about to drop, and it's gonna be quite a bit. So you better get going. You better get on that. All right then. Let's do it. Oh, there's a dab. It's like a way to crack your neck. Definitely stay up and do 11. Be like me. I stayed up all night working on this on 12. For you guys, because I wanted to get it done as soon as possible. 2-for-1 dab. Discount Thursday, apparently from Wowings or whatever. Alright. I will let you all go now, because I'm tired too, and I gotta get that done. So, until next time, which will be almost our last time, I look forward to talking to you on Discord on the weekend about the assignment. I've never drunk coffee in my life. I'm not a coffee drinker or energy drink. I don't drink caffeine at all. It's not for religious reasons or anything. I just don't like it. people are pretty shocked about how I got a CS degree and not drink coffee either. I just somehow did it. All right then, guys. I'll see you all next time. Until then, rush B, no stop.